Hello everyone. In this video, let's solve some problems in Fourier series. That is, given a function in the given interval, we are going to express that in terms of sines and cosines. Consider this example: f of x is equal to x square. What is the interval? They have given minus pi to pi. So we are going to obtain the Fourier series, and after that we are going to deduce this. Okay. So before solving any problem in Fourier series, first let's think about the Dirichlet condition. Of course, no need to check a Dirichlet condition for each and every smooth function, but still f of x is equal to x square. It's periodic in minus pi to pi. The pattern is going to repeat after the interval. As I told you, try to plot the graph to get an idea about it, and it's a very continuous function. So it has finite number of discontinuities. Of course, it has finite number of maxima and minima. It's a single valued function. It satisfies all the conditions. So definitely, if I express this function in terms of sines and cosine, that series is going to converge. So eventually, no need to check Dirichlet condition in smooth functions, but still keep that in mind, that it should satisfy Dirichlet condition. Now moving directly into the problem. First of all, this is the formula. F of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. What we have to do? We have to find a0, an, bn, substitute in the equation. Because the corresponding a0, an, bn for the function x square, and left hand side f of x is nothing but x square. So you are going to express x square in terms of a constant, cos and sine terms. So as I told you, checking whether a function is even or odd is very important. In case if we don't check, what will happen? That is what we are going to do in this problem. After that, from the next problem onwards, we'll check it. So first, what is the formula for a0? a0 is 1 by pi integral minus pi to pi, because the given interval is minus pi to pi. In case if they have given 0 to 2 pi, we will write 0 to 2 pi. Okay. So 1 by pi integral minus pi to pi f of x dx. This is the formula. 1 by pi integral minus pi to pi. What is my function f of x? X square. If I integrate x square, I will get x power 3 by 3, because integration of x power n formula is x power n plus 1 by n plus 1. Here in the place of n we have 2. Simple integration. And we are going to apply the limit. Lower limit is minus pi, upper limit is pi. How we will apply the limit? Upper limit minus lower limit. So this 3 is just a constant. So always keep only the x terms inside the bracket. Remove all the constants. So 1 by 3 pi. Inside the bracket only x term is x cube. And upper limit is pi and lower limit is minus pi. We are going to substitute upper limit first. Pi cube I have written, minus this minus sign, lower limit is minus pi the whole cube. So and this is minus pi the whole cube. So since it's a power 3, we will get a negative sign here, and this negative sign will become positive. So pi cube plus pi cube we will get 2 pi cube by 3 pi, and pi will get cancelled, 2 pi square by 3. We got first value a0 to substitute over there. Here again I repeat, I didn't check whether my function is even or odd. Just I am finding a0, an and bn. The same problem we will solve it by checking even or odd, because there is a reason behind it. Now let's go for an. What is the formula for an? 1 by pi integral minus pi to pi f of x cos nx dx. This is the formula. Always an cos term will come. For bn, sin term will come. If the same problem is in the interval 0 to 2 pi, what we will do? 1 by pi integral 0 to 2 pi we will write. That's it. F of x. Here my function f of x is what is given in the question. So I have written x square cos nx dx. So the moment you see multiplication and integration, you will think integration by parts. Of course, you can do integration by parts, but since the power is x square, it's great. So it's like you have to repeat twice, thrice. The same thing we'll say that we can solve it by using Bernoulli's equation. So what we are going to do is, out of these two terms, just check which term is going to vanish after differentiation. So now which term is going to vanish? That is x square. If I differentiate x square, next step it will become 2x. 2x again if I differentiate it will become 2. 2 if I differentiate it will become 1. Because this cos or sine, whatever it is there, cos will become sine in the first differentiation, sine will become cos in the second differentiation. It will be keep on repeating. It will not vanish. So keep this term as it is. I am just explaining without any formula. Just follow me. This is x square. Okay. The signs, alternate signs will come. This is plus. Then you put a minus sign over here. Next step you will put a plus sign. That's it. So x square differentiation is 2x. 2x differentiation is 2. Okay. So the term that's going to vanish, you are going to differentiate. First you write the term, then next differentiate once, then differentiate again. So what about the sign? First term is plus, second term is minus, third term is plus. This Bernoulli's we'll be keep on using it for all the integration if it's in multiplication. So try to be clear with the concept. The second term is there, right? That we are going to integrate. Okay. Cos nx, if you integrate, you will get sin nx by n. Sin nx, if you integrate, minus cos nx by n. Don't get confused. Sin nx differentiation is cos nx into n. But here we are not differentiating, we are integrating. So sin integration is minus cos. Minus cos nx by n. Already one n is there, right? So I have written n square. Next term, cos integration is sin. Plus sign only, cos integration. Already this minus sign is there, no? We are just taking it to the next term. So cos nx integration is sin nx by n. Already n square is there. So n square into n will become n cube. Okay. So only alternate signs here, plus, minus, plus. Other thing we didn't touch any sign. We are just writing first term as it is. Second term is integration. After this again I am integrating this. Again I am integrating this. So minus pi to pi. Here the moment you see the terms, wherever sin nx is there, this term will become 0. Because sin n pi is 0 when n is an integer. So automatically the first term will become 0, third term will become 0 because sin n pi value is always 0. And only this term will be left over to apply the limit. As I told you, just take out all the constants. Okay. So what are the constants? This term. Already 1 by pi is there outside. This and this minus will become plus 2 by n square. So 2 by pi n square. What are the terms left? X cos nx and minus pi to pi. We are just going to apply the upper limit. Wherever x is there, replace it by pi. So pi cos n pi. I have written minus lower limit. Wherever x is there, replace it by minus pi. Minus pi cos n minus pi. But here cos of minus n theta is nothing but cos n theta. So within the bracket, even if minus sign comes, it will become cos n pi because cos is an even function. So keep this in mind. If it's sine of n into minus pi, if you have this, then automatically we will write minus sine n pi because it's an odd function. For sine, the negative will come out. Here we are just applying in the place of x minus pi, cos n minus pi is nothing but cos n pi. So the sign didn't change. Okay. So this minus and this minus will become plus. So we will get 2 by pi n square into 2 pi cos n pi. This pi and this pi will get cancelled. And always cos n pi value is minus 1 power n. You can write this as a formula. Cos n pi is equal to minus 1 power n. Sin n pi is equal to 0. These are the basic formulas we have used. What are the? Cos n pi is minus 1 power n. Sin n pi is 0. Cos of minus n theta is plus cos n theta. That's it. We have done a simple integration, and we got this answer, an. 4 by n square into minus 1 power n. So we got a naught, we got an, because that is what we want in this formula. If you remember, we got a naught, we got an. What we have to find? Bn. Yes. What is the formula for Bn? 1 by pi integral minus pi to pi f of x sin nx dx. Always for an you will get cos nx, for Bn sin nx. This formula is always same. Again, limit in the problem they have given minus pi to pi. So I have written this. So 1 by pi integral minus pi to pi x square sin nx dx. Okay. So I am writing x square as it is. Same thing. In integration of multiplication is there. Repeated integration by parts we will do. So the term that's going to vanish, I will write first x square. See here, plus. X square differentiation is 2x. What is the second sign? Minus. 2x differentiation is 2. What is the third sign? Plus. If there is a next term, in case if it exists, that sign will be minus. So always it starts from plus, minus, plus, etc. After 2, the differentiation is 0, so we stopped with this. And then sin nx, we are going to integrate. If you integrate sin nx, we will get minus cos nx by n. Cos nx integration is sin nx by n. Already one n is there, so it will become n square. This minus sign, I am just taking it as it is. Next, again, sin nx integration is minus cos nx. So already this minus and integration, after integration one more minus will come, so it became plus here. So cos nx by n, already one n square is there, n square into n will become n cube. Very simple, similar procedure. And limit is minus pi to pi. So the moment you see sin nx and the limit minus pi to pi, we know that this term is going to become 0. So only we will be having these two terms. And as I told already, take out the constant. 1 by n is just a constant. Apply the upper limit. Upper limit is pi, correct? X square is there. So pi square into cos n pi. If here the negative sign itself I have taken outside. It's all your wish. Just not to get confused. So minus 1 by n I have taken outside. So if you just apply the limit, pi square cos n pi minus pi square cos n pi. So this and this will get cancelled, we will get 0. And second term, 2 by n cube into cos n pi. If you apply cos n pi minus cos n pi, again you will get 0. So what is the answer? 0. So we worked till here and we got the answer as 0. What is the formula for f of x? A naught by 2. A naught we got it as 2 pi square by 3 by 2 plus summation n is equal to 1 to infinity. A n is, we got the answer as 4 into minus 1 power n by n square cos nx. And bn is 0, so we didn't write the third term. Now coming to the checking procedure. In the beginning I told you we didn't check whether the function is even or odd, right? There are two ways to check. Either you can check graphically or you can check mathematically. How to check graphically? What you are going to do is just going to draw the graph. Okay. X square, function x square is on one side and corresponding y value we are going to write. Put x square, x as 0, function x square is equal to y. If I put x as 0, y will become 0, so 0 comma 0 is first point. Second point, put x as 1, x square will become 1. So this point is 1 comma 1. This is the second point. Put x as minus 1, minus 1 square, again it will become plus 1. So minus 1 comma 1 is the next point. So your graph will be like this. Put x as 2, then what you will get? 2 square, it will become 4. So 2 comma 4 is on this side. Put x as minus 2, you will get minus 2 comma 4 on the other side. So your graph is going to be like this approximately. I don't have proper space to finish this. So if you see this, this is just a mirror image. This image is just on the other side, symmetric. So the function is even. So in case, okay, you are saying that I don't have time to plot the graph or I am getting confused, then you can check mathematically. What is the way to check mathematically? Here first of all, you have to see the question. The interval is minus pi comma pi. If they say the interval is minus pi comma pi, in your function, replace x by minus x. F of x is x square, right? So, in the place of x square, you are going to change minus x. So, f of minus x is minus x the whole square. This is nothing but x square. You are getting the same function. I'll write this neatly again. Yes. So, replace x by minus x if the interval is minus pi comma pi. Okay, here the function is minus pi to pi. So, I have replaced x by minus x. So, it is minus x the whole square. So, it's nothing but x square, the given function itself. So, if you get the same function after replacing x by minus x, then we know that the function is even in the interval minus pi comma pi. Please keep this in mind, because in the interval 0 to 2 pi, the checking procedure is different. If it's minus a to a, replace x by minus x. So, I checked graphically also, I checked mathematically also, the function is even. So, what will happen when the function is even? Then Bn will become 0. So, if we know that the function is even, then in that case Bn will become 0. Why so? If you see the formula for Bn, here it is. F of x sin nx. This function f of x, x square is even. Sin is odd. Even function into odd function. This combination overall it's an odd. Any odd function in the interval minus a to a or minus pi to pi is 0. No need to even calculate. Even if I calculate, I will get 0. Okay. So, that is the reason we are checking for even or odd. This helps our procedure time. No need to do this integration at all if you know the function is even. So, the good thing is, if the function is even, then Bn will become 0. What will happen if the function is odd? Then it's very good. In that case, a0 and an will become 0. Only you have to find Bn. That's it. So now you'll think that it's better to check whether the function is even or odd before solving it. But there is a slight change in the formula. There you wrote 1 by pi integral minus pi to pi in the formula, right? So here you are going to write 2 by pi integral 0 to pi. Why? It's like this side in integration, whatever answer is going to get, this is area under the curve, right? So automatically this answer is also going to be the same. So why to waste time from minus pi to pi? So we'll find only 0 to pi, multiply it by 2 to get this. So if I know this, I can guess this. So that is what we are doing. So only 1/2, 0 to pi. I'm going very slow. First try to understand the mild difference. So once you have decided that, yes, I'm going to check whether the function is even or odd, and then your function is, sometimes it will be even, sometimes if it's odd, then you have to use this formula. Okay. So instead of writing 1 by pi, what you're going to write? 2 by pi integral 0 to pi f of x dx. 2 by pi integral 0 to pi. Here the function is x square dx. X square integration is x cube by 3. Same thing. Only the limit changes, 0 to pi. If you apply the upper limit, you will get 2 pi cube by 3 pi. If you simplify, 2 pi square by 3. Same a0 you got. There is nothing difference in the integration, only the limit changes. So, please keep in mind, it was originally 1 by pi integral minus pi to pi. Now, 2 by pi integral 0 to pi. Same way, for an, can you guess the formula? 2 by pi integral 0 to pi f of x cos nx dx. Because the function is even, cos is also even, combination of even function is even. Even means no need to find two things, only one side I will find it, multiply by 2. That is why this 2 is there in the numerator. So if you simplify this, you will get the same answer. And once we have written in the paper that yes, the function is even, either you have to prove it graphically or you have to prove it mathematically, then directly you can find a0 an, no need to find bn, and you can write bn is equal to 0. So this is the advantage of finding whether a function is even or odd. So you'll get the same answer. And one more thing, most of the problems they'll give deduce that. So what is the advantage of it? If your answer is correct, you will get the deduced result. So f of x is equal to, my function is f of x is equal to pi square by 3, 2 and 2 will get cancelled, plus summation n is equal to 1 to infinity 4 into minus 1 power n by n square cos nx. So I'm in the interval minus pi to pi, there are so many points, correct? Plus pi by 2 is there, minus pi by 2 is there, and here it's an open interval. So minus pi and plus pi are not included in the interval. If it's a closed, if I write like this, it's a closed interval. Then in that case, both the values will be there. So I have to choose any value in between minus pi to pi and substitute in the equation to get the desired result. So here I am choosing 0. Now you will get a doubt why we have to choose 0. We will do more problems to get idea about it. So put x as 0. So f of 0 will become 0. And here pi square by 3 is just a constant. Summation is equal to 1 to infinity 4 into minus 1 power n by n square cos x, right? Cos 0. What is cos 0? 1. So you will get this. Plus pi square by 3. If I push it to the other side, I will get minus pi square by 3. And 4 I will bring it down. Pi square by 12. This negative sign, I will push it to the other side. So if you put n is equal to 1, what you will get? Minus 1 power 1. That is minus 1 by 1 square. This minus sign, if it comes, it will become plus 1 by 1 square. Second term will become minus. Put n is equal to 2, minus 1 power 2 by 2 square. So 1 by 2 square. Because of this minus sign, this became minus. So we got the deduced result. Once if you get the proper deduced result, it means whatever you have written as a summation is correct. So I am saying that f of x is equal to x square can be expressed only in terms of cosine terms because the function is even function. So hereafter we are going to check each and every problem whether the function is even or odd to reduce our calculation time. But in case if the problem turns out to be neither even nor odd, then we have to find all the a0, an and bn values. Thank you.